Welcome to Colorlight online training series. This is Frank. Today's topic is loading capacity. This topic will talk about what is the loading capacity, what factors will affect the loading capacity, and the loading capacity of each series in our control system. We hope this class will help you to develop knowledge about controller and learn how to calculate the loading capacity in different projects. We will not go too deep on particular topics, and it will be very easy to understand. Because this group is large, I might be unable to open everyone's microphone. Please type your question in the chat window as the pictures showed. We got our support team who are standing by answering your questions came across the chat window. Today's training will take around 20 minutes. Then we will leave the remaining time for answering some of the questions at the end. Don't forget to follow us on YouTube to check our recorded videos. Alright, I appreciate everyone's appreciation here. Let's get started today's training. Before we start to explain that what is the loading capacity, let's see the pictures. How to calculate the resolution of a cabinet. I think this is very easy for most of you guys. But maybe some of us have just joined this LED industry, so I want to introduce this concept to them. Usually, we will get those information from the manufacturer, module, or cabinet's dimension, and pixel pitch. Pixel pitch is the distance from an LED to the next LED. The unit is millimetered. When the cabinet dimension is divided by the pixel pitch, we can easily calculate how many pixels on width and height. For example, there is a P3.9 cabinet, which is widely used in rental projects. The size is 500 by 500 millimeters. After calculating, we can get the result of the resolution. It is 128 by 128. So, what is the loading capacity in LED control system? There is two different pitches of the cabinets. The first one is P1.9. The resolution is 256 by 256. Another one is P3.9. The resolution is 128 by 128. The dimension of these two cabinets are the same. They are all 500 by 500. When we do the mapping on the software, as the picture on your right hand, we just follow the resolution of the cabinet, not the physical size. So for the control system, dimension is not a factor to consider for us and won't affect the loading capacity. We only focus on the pixels. If you are not using our control system for the first time, you should hear about the limitation of each output port. It's 650,000 pixels. It means the maximum loading capacity for one Ethernet cable. What is the basic for calculate the total pixels? In control system, there is word called control areas, like the blue rectangle. It is a rectangular area from the start point in the upper left to the pixel in the lower right. For example, there is no cabinet on the lower right here, but the blank areas will also eat pixels. So the total pixel of port 1 will be considered as a cabinet by the software. In the same way, there's a cabinet in port 2. We can see that The software will also eat all the pixels in blank area even though there's no cabinet in those parts. So the total loading capacity is 16 cabinets for this part. As long as the total number of the pixels in the control areas is not over 650,000 pixels, then the system can display the screen correctly. For sure, different device has a restriction on width and height. We will talk about different device capacity on the second part. Perhaps you might be interested why this number is 650,000 pixels. Why cannot be 6 million or more? Currently, the control system is based on network communications. Network cable transmission has those advantages: stable, long distance, and high-speed transmission. The transmission distance of Cat5e can reach 100 meters. The maximum transmission speed is 1 gigabyte. Let's see. There is a formula to calculate the maximum loading capacity. The maximum bandwidth of Ethernet cable is fixed, 1 gigabyte. The usage rate means how many percentage of 1 gigabyte can be used to transmit data. The data is transmitted in the form of data pack, like this, like the blue rectangle. The red part is the head of a packet. It will tell the receiving card that the data is ready to be received. The orange part is the data. The green part is the end of packet. When the receiving card recognizes this part, it will start to receiving data. Also, there will be many interval time between each package. The white color part. If we remove all those interval time, head, and the end of package, the rest is the data. It's around 90% of total bandwidth. So keep going and check the formula. The maximum capacity for one output port is transmission bandwidth multiplied by usage rate, then divided by the frame rate and color depth. Normally, the frame rate is calculated according to 60 Hz. During the 8-bit input source, we know that each pixel is composed of 3 colors: red, green, and blue. So the data of one pixel is 24 bits. Finally, we will get the result is around 650,000 pixels. That's how this number came from. As we know the preview formula of loading capacity, there are two main factors that affect the maximum capacity: frame rate and the color depth of the input source. In theory, if you reduce the frame rate to 50 or 30 Hz, each output port can handle more pixels. But in order to ensure the image quality and performance, we will recommend that the maximum loading capacity should not exceed 650,000 pixels. In some special applications, like Active 3D, the video frame rate will reach to 120 Hz. In this case, if the frame rate is double, So the loading capacity is only a half of the original. When we are making a project for 3D, we need to double the number of controllers. Color depth is another factor affecting loading capacity. As the color depth increased, each pixel means more data need to be transmitted. For example, if the video frame rate increased from 8-bit to 10-bit, the image will get more details, but the amount of data for each color is increased and the pixel capacity is reduced. In our system, the video color depth is increased to the 10-bit. The loading capacity of each output port is 75% of the 8-bit. Second part, I will introduce the different loading capacity in our product line and show how to choose controllers through a simple case. Firstly, we are talking about X series. X series is big sender in Colorlight, which can realize that displaying video source on the screen pixel by pixel, and there is no video processing function built in. Currently, there are 3 modules in X series. X2 has 2 outputs, X4 has 4, and X6 have had 6 outputs and 2.5 GB fiber output. Let's take a look at this graphic. They are respectively loaded with 1.3 million pixels and 2.3 million pixels. About S6F, it has the same capacity as S4. In some fine pitch projects, it had the advantage of wiring with 6 outputs. So we don't need to add another sender when the resolution within 2K. You may have the questions, why the capacity of 2 output ports is 1.3 million pixels. The X4 with 4 output ports is 2.3 million pixels, but not 2.6 million. Let's see these pictures. Think of the device signal interface as a tap and the water pipe 1. The water is came from here. The maximum resolution of the single-link DVI-D is 1920 by 1200 pixels. The water pipe 2 is the output of S4 sender, and the total pixels of 4 output is 2.6 million pixels. Because the input resolution limits the output resolution, so the loading capacity of the X4 and X6F is 2.3 million pixels. X-series processor is integrated with standard and video processor, and on X16, it's integrated with the splicer. Let's have a quick look on some typical modules from X-series, X2X, X4X, X8, and X16. They are designed for different resolution of the screen, from the half of 2K to the 4K resolution. The main difference of those products is the quantity of the output ports. Because of the scaling feature, the maximum loading capacity of X4X is up to 2.6 million pixels. On your right hand, there is the restriction on width and height. For example, X16, the maximum width and height is this one. So you don't need a splicer when the total pixel of width is less than 8192 pixels. The last series is Z series. Basically, Z series has three members: Z4, Z6, and the Z6 Pro. Compared with the X series, Z series provide more high-end features like HDR, low latency, and 3D. Z4 is entry-level 2K processor, and it can handle 2.6 million pixels. Z4 can handle 8.3 million pixels. The maximum resolution is 3840 by 2160. Z6 Pro is an advanced processor. It had 4 optical fiber output ports instead of the Ethernet ports, 2 for the main, 2 for the backup. Each fiber connector uses 10 gigabytes. So the maximum loading capacity is 8.8 million pixels. And more details about Z series or X series, you can follow us on YouTube Colorlight Technology and watch the preview videos. So today we don't show too much details on this topic. Finally, I want to share you with a simple case, how to achieve the best solution in consideration of the resolution and cost. Let's check the screen information. The dimension, pixel pitch, and whole screen is 5 by 5 cabinet. We can get the resolution of the cabinet and the whole screen by calculating here. Whole screen is 1920 by 1080. It is a standard 2K resolution. But we may find a problem. There is 5 columns in the whole screen, and one output port cannot handle 2 columns. It is overloading. It is costlier if we choose 2 pieces of X4 senders to handle this project. Also, we need a HDMI splitter in front of 2 senders. Therefore, the X6F sender meets this kind of requirement. Let's take a look on this mapping diagram. 5 network cables are used to distribute the loading. Each output port is 5 cabinet. For end users, they don't need to buy another device and easily to set up those kind of fine-pitch projects. Alright, that's gonna to be all for today's training. In the remaining time, if you have any questions about this training, please send your question to the chat window or raise your hand in the software so that we can unmute you. Thank you.